Okay, we'll make a start. Good afternoon, ladies and gentlemen. I'm Andy Hind. I've been at Alfresco since day one, and I've worked on authentication, authorization, search, query, and more recently I'm involved in the CMIS TCK, so if you have any questions on those things, then try and catch me when you can, and I'll see what I can do for you. But today, I'm here to talk about querying for metadata. It might be slightly misleading. We've always been able to query for metadata using SOLR or Lucene, but today we're going to talk about something specific. To start and put this into context, search, really, we're always talking about a box somewhere, and somebody puts a query in there, we execute that query and come back with a bunch of results. And what I'm really going to talk about is what's behind that box, what's in that box, and what makes it work, and then talk about one particular implementation specifically today. So the next question is, where is that box? Because that makes a lot of difference to how we execute the query, what results you see, and what happens, whether it's what you type in that actually goes off, or whether somebody mucks about with it and changes that query to do something else on your behalf. And in some bits of Alfresco, what you type in is what you get. In other bits, there's definitely a lot of mangling goes on there, and some things you might not expect happen. Hopefully it's simple, but the smarts are under the cover, and in the end, it does what you want, and I've got the messaging in there, so we're all good. So, if you go to the bottom of the box, we hit the Java layer. So there's lots of stuff can happen in Share or in RM or any module that's on top of Alfresco. But when you get down to the bottom of it, when you execute a query, it all ends up in the same place. So there's a Java Search API, and essentially what happens is a query comes in, and somehow there's some context that goes with that query. We won't worry about what that is, but it is important. And out of that API comes a list of nodes, references to nodes, of the ones that you can see that best match your query in some way. So beneath that Java API, there's some implementation stuff, and we have different search subsystems. So we currently have a SOLR search subsystem, a Lucene search subsystem, and no search subsystem, and they're about executing your query. Whilst I was outside, I was listening to people saying, do we have to rewrite our queries for different implementations? The answer is no. There's an abstraction above there, which is the query language. So Alfresco full text search and the CMIS query language are things in their own right. And when you execute a query, it goes through the layers, and we build some abstract form. So the two different query languages are parsed into a common structure, and then we actually take that and we execute that against one of the query engines we could use. So at the moment, you could either do it against nothing, you could do it against the old Lucene stuff. We can send it over the wire and across to SOLR, where again it happens to get reparsed and then executes over there and comes back. And that's basically what there is today. So that abstract form includes all of the things you would expect. So things like doing exact matches, doing logical operations, matching for terms, doing ordering, looking for specific types. All of those things are described in that abstract query form, and then we take that and actually do the work and come back with the answer. So if you're ever worried about rewriting queries for different database engines or different implementations, it doesn't matter. The query stays the same, and the smarts take care of executing it in different ways. So what we're here to talk about today, in particular, is executing queries against the database. We'll talk about why in a minute. And so where we've before had an index engine, should we call it, which uses either SOLR or Lucene, we now have a database engine, and that ends up executing the query against the database. And there's a bit of clever stuff that happens at the query layer where it chooses or can choose which implementation to use to answer your question. And we'll go into the details about why it might make that choice and how you can control that choice. But what it comes down to is that if you can execute the query against the database At the moment, we will by default if you install 4.2 today. But there are lots of caveats to that, and we'll cover those next. So hopefully that puts in context what we're talking about, how it all ties together, and that there's a new implementation under the covers. And the question you're asking is, why is there a new implementation? So those of you who've been with Alfresco for a while will remember that we started off with Lucene. And if you were to use a single node Alfresco instance with Lucene, you'd be forgiven to believe that you had transactional consistency and it was immediately consistent. And that's true in one node. But if you were to have a cluster with several things using Lucene in there, it would appear that you had that consistency, but in fact you didn't. What happens in an Alfresco cluster using Lucene is the individual elements in that cluster are tracking the changes in the database and updating the things that happen on the other node in the background. So things that happen on a particular node, then those things are transactional. So the things that you did, you would be able to see, but you wouldn't necessarily be able to see anything else. That's assuming that your sessions are sticky and you stick to the same instance in the cluster. That in itself had lots of issues, and we moved to SOLR to implement search in place of Lucene. And SOLR obviously has an issue in that we're tracking stuff. We're not pushing things in there and waiting for that push to complete before finishing a transaction in Alfresco. And so we've moved to an eventually consistent model as opposed to something that was quite close to or made you believe you had a transactional model. So if we go to the database, we get a transactional result. And the main reason we are doing database queries is for consistency. Lots of people want to see the results as they were. And that makes sense in one context, and that's only if we're thinking about metadata. Content indexing obviously takes time. There's other things we have to do. We have to transform the content. We have to make it searchable, and that is quite a costly operation. And so that's mostly why SOLR is further behind than you might expect. We have some constraints here, and that when we set out to implement this DB query engine, we were not going to go and change the schema that we currently use to store properties. And that gives us some other features and drawbacks. It's not ideal for querying against, but we have done our best, and I'll tell you what the limitations are. Have many people in the room used canned queries, written their own canned queries? Anybody who's really shy written their own canned query? There's a couple of gentle waves I've seen. Okay, so some of the things I'm saying also apply to canned queries. The types of queries you're typically going to do in canned queries are very similar to the kind of general metadata query you would expect. And it's possible that the DB query engine could replace that in the longer term, but some of the things that are added to Alfresco to support database queries also support canned queries in general. The other thing we concentrated on was delivering something that implemented the CMIS query language in particular. And there's one strong use case for this, and that's that Alfresco Workdesk uses the CMIS query language to find folders and other things. And it's also very easy to define what's in and what's out, so it's clear which things we support in querying the database and which things we do not. You can also cover it in Alfresco FTS, which is also supported, but maybe it's a little bit more confusing and less clear-cut as to which things you can expect to work and which things maybe you can't. So we'll go through the bits of the query language, and we'll say what's in and what's out, and why, hopefully. So, in general, you can ask most questions of the database except for the things that you see on your left over there. So we're not going to cover full text, so things are not going to be, you're not going to be able to search for content at all. You may be able to search for some metadata about the content, but not the content itself. We've excluded the OR operator, And that's partially, well, that's mainly because we're going against the database, and depending on what query you type in, or may get you into some performance trouble, because the database has more difficulty optimizing queries that contain OR. Now, you can say, well, my query's fine. Tough. We have decided that's how we're going to go, and in the future we might do something else to support some cases, but at the moment there are none. And our schema that we store properties in has an effect too, and that means we can only query certain property types, data types. And we do not, at the moment, currently support querying against decimal types, so float and double are not supported. Boolean's not supported, which is quite irritating on the whole, because there are quite a lot of metadata things that are true or false. Yeah, I know, it's annoying to me as well, but the reason behind it is that for every type we have to support, we end up adding an index to the database. And that means that we increase the size of the database effectively. And so we have limited the number of property types that we support effectively based on that. The other thing that we do not support in the database queries are structural queries. So in the CMIS sense, that's the in-tree stuff. Now, in-tree is a simple form of structure query compared with the full path queries that you'd expect to find in general. And things may change with regard to whether in-tree is in or out. Currently it's out, but that's the one you can expect to move across to be supported by the database first. In terms of which types you can select in your CMIS query, you can do CMIS document, CMIS folder, and CMIS secondary types for those of you who've moved on to CMIS 1.1. We do not do the extra things, CMIS item, CMIS policy, and CMIS relationship. CMIS item would be very useful, but we're not yet there, so you can expect that one to appear. Policies and relationships are not going to appear except for the magic that wraps policies as aspects as policies, sorry. So anything that derives from CMIS document, CMIS folder, CMIS secondary type, you can query for in your CMIS queries, and it can go to the database just like you can from CMIS queries today. And to cover the kind of data types from the CMIS point of view, the things that are supported are strings, and we have the kind of, it's got to be less than 1,024 characters, and that's a feature of how we store strings in our current schema. So if you are looking for long properties, then the DB query unfortunately is not for you. It supports integers and long. It supports the CMIS ID type and the date types. So just to reiterate, things that we don't support, you're not going to be surprised by Boolean and decimal, because we've already covered those in the grand summary of things. URIs, we don't really support for query anyway, and it's not going to be in the DB either. And same for HTML types, and long strings are not going to be there. And this comes down to, again, as I said, we don't index booleans, longs, floats, booleans, floats, doubles, and strings completely in the Alfresco schema. If you really want to know, things over 1024 get turned into a blob type thing, and they don't really index as well, and it indexes in a different way, so that's tough. So as well as those properties in general, we do some specific ones. So the things you would expect to be able to query against for CMIS documents and CMIS folder, things like the content type and content length, in addition to those properties, are supported. So we've got those, most of the things that are queryable are in there. I'll take questions at the end, okay? So we support and is good, because it's generally increasing the selectivity of any of the queries that you execute. The rest of them tend not to be, we're talking about less selective queries if you use not or any for multi-valued properties, or not any for multi-valued properties. And as I've already said, we're not going to support or, and if we ever do support or, it'll be in a limited case. The reason why any causes a bit of trouble is we're talking about multi-valued properties. If you happen to match more than one multi-valued property for a particular row, in the database terms, we're doing we're joining on the database, and so multi-valued properties can give you more rows than you expect, depending on how many of those multi-valued properties actually match your query. So it's okay, but it potentially increases your result set size that has to be handled on the database end. Or, whilst it isn't very good on the database, SOLR is really good at OR expressions, as it turns out. Much better than we're ever going to be able to do on the database side, because it can just skip through the whole lot together, and the database has to actually build all the results and do the rest of the stuff to follow through. So the way things are indexed in SOLR per document helps a lot in executing that query. We don't have to put all those properties together as we do on the database side. At some point in the future, we may move from our kind of inner join stroke outer join implementation and do semi-join stuff, and that will keep the row count down, but that's not today. Right, back to the query language. There are lots of predicates defined in the CMIS query language, and if your type supports a predicate, then as it happens, so do we. So any of those things equal to, and using the multi-valued properties as well, using the any keyword, they're all supported. For the rest of them, we support in and not in, and like, and not like, is not null, in folder, any and not in, all of those are in there. As you'd expect, as we're not doing full text search, contains is not supported, and score is not supported. And as I've already said before, in tree is not supported. So when you're using not, obviously we're making things not selective, and I would caution against it. Is null means that we have to do an outer join in the database implementation. So when we do that, obviously we're considering lots more things in there to actually answer your question. So it tends to be marginally less performant than is not null, for example. Like we do support. We had some discussions about whether we should support like, whether we should support all versions of like. In the end, we have shipped supporting all versions. Some databases are better than others actually executing the end query that's generated. So we do support everything. If you end up doing a leading wildcard, you put the % in the front, then yeah, it's going to be not so good as if you didn't, but it turns out to be not that bad on the whole. So if the rest of your query has some selectivity, we've already got some things in there on type. If you're joining to aspects, if you've actually put an equality predicate in there, for example, then like is not going to be that bad. It all depends on the number of things it's going to consider in the query. So, you know, whilst this might be simple and smart in some ways, you have to also be quite smart and not so simple when you're thinking about the queries that you execute. Because they are going to go to the database, and some of you know that those queries are not going to be as good as if you did them against SOLR, and you can get into a little bit of trouble, and you just have to be aware of that. Right, in terms of ordering properties, yep, you can do all of that. We don't make any distinction on ordering by the types that we've talked about. If we've said the property type is supported, you can order on it. There's some DB variation in the performance, and if you've got large result sets and you're ordering large result sets, the same gotchas for ordering in general on databases might come and get you. We don't order by IDs, but we may in the future. We do order by IDs in the other indexing things, so that's one of the, I think that's the only difference, but again, we don't have to do that according to the CMIS spec, so we're compliant in terms of the CMIS query language. If you select from CMIS document and order by CMIS name, and you have 10 million documents in your repository, you will have to wait a bit of time. And if you want to know how long, I would say about 30 seconds. Again, it depends on your DB and your configuration and all sorts of other things, but that's typical on some databases. That's the kind of top end of things. Some are better than others. So if anybody can read that at the back, I'd like a little wave. This is a generic query that we use for, it's an unselective query that has many terms that is in general, you know, a not so good query to run. It's got a like that has a poor pattern. It has created by and creation date in there that have poor ranges and that kind of things. So we've used this to work out whether things are good or bad. It's just there as an example of the things you can do up there. The queries you can write are quite complicated, as long as you stay away from OR. And my advice again is to be selective in the queries that you run. So specific types you've always got to have in the CMIS query language. You can use the in folder stuff, and that gets you quite a lot of use cases. And joins to aspects are good, and equality is good. And those things in generally are not so good. I'm not going to go through them all, but you know, the less specific your query is, the poorer it's going to be on performance. And it turns out that SOLR is actually much more stable at that kind of poor query. Sometimes it's generating big long lists of things to do ORs against, and it's not so great, but it still seems to beat the database most of the time, just so you know. But it doesn't give you consistency. So we've gone through the restrictions that there are on using queries against the database. And just to recap, we're not supporting full text search, we're not supporting the OR predicate, decimal types and Boolean types are out, so are a few very long strings, and we're not supporting in tree. So that's the background, that's what we support, the reasons why we support it. There are some other subtle differences between SOLR and the database for things that we do support. So the two implementations are not the same. If both can answer the same query, the answer that they come back with might be subtly different. And those differences are really about the order in which you'll see the results, and potentially about the matching as well. So the database is likely to come back in some order represented by some index that drove the query plan, whatever that might be. There's no concept of scoring on the database in terms of a natural ordering of the results. If you execute the same query against SOLR or Lucene, it is always going to do some kind of scoring, and there will be some kind of ranking of those results, even using and, the kind of terms that have shorter things that match will rank higher. So there'll be some subtle differences in ordering. I don't think it's a big deal, but you need to be aware about that, because when we pick which of the implementations we're using, sometimes it might go against the database and sometimes against SOLR, and you might just see some subtle ordering differences. And you changed your query very slightly, and the results seem to be not quite the same. And that's one of the explanations why that can happen. So there are some other differences between the implementations. One of the major differences is how we evaluate permissions. So on the SOLR side, which is always going to be pointing to the left for consistency, we execute the permissions and access controls as part of the query. SOLR is enforcing your access rights. So when the results come back from SOLR, it only includes what you can see. It also takes into account the fact that we can hide some nodes. So there's a hidden data type and some special data types that are not indexed in SOLR or in Lucene. And when you execute your query, you will not find them. It doesn't matter what query you execute. They will not come back because they're not in the index to find. On the database side, we don't respect that hidden aspect and the control of indexing. And this is where the choice to pick or exclude Booleans doesn't help us, because we would have had to support Booleans to exclude those things. So we haven't done that. So you can see everything using the DB engine. And for some use cases, that is what you want. And we will have, at some point, we will be able to exclude them or include them. The main issue is that we're evaluating the permissions after the execution of the query when we go to the database engine. So we have to pull back all the results. Even if you only see 1 in a million, we're going to pull back the million. Now, improving that is on our list of things to do, but in the time we had available, that's the best we could do, and it uses the same model as the rest of the repository. So what we used to do for Lucene queries, what we do if you go and ask for children of a node, it's going through and evaluating for all the ones that come back which ones you can see. And that does mean that we have to pull back more from the database than we would like. So just be aware of that as well. Normally that doesn't make a big difference to things. It's just how long it takes to get the list of IDs from the database that match the query, and then it's down to how fast you can filter them. And the other major difference between using SOLR and Lucene and the database is how it handles localization. If you're using SOLR, everything is localized. When you do equality matching, it's doing an exact match. When you use the CMIS API, there's no way of controlling that unless you go in and change the way that SOLR tokenizes exact matching stuff. And if you order things in SOLR, it gets ordered correctly according to your locale. French will order correctly, Spanish will order correctly, English will order correctly, and it will do what you expect. On the database, things are different. So we're not creating indexes to support different localized ordering. You are stuck with your database collation scheme, whatever that might be. And it will order according to that collation scheme, and it will do equality matching according to that collation scheme. So some people with some databases will have case-sensitive matching, and some people have case-insensitive matching. It all comes down to what your database collation does and where you're executing the query. And ML text is an odd case. In SOLR, when you query against an ML text property, it will also make sure that the locale that you're using is matches. In the database world, it doesn't include the locale as part of the match. It will just match any one of the ML text properties regardless of the locale you're currently searching in. And ML text is one of those slightly odd things, is that behind the scenes, it's a multi-valued property. So that can, if you happen to have lots of titles that contain the same word but in different languages, that gives us a slight blowout in the result sets potentially that we consider when we're executing the query against the database. Right, I digress. So, why I get up in the morning. This is kind of like the Daily Mail headline, which would have been why I'm not stabbed to death in the night. So, I'm unusual, as it turns out, amongst our developers, in that my other half uses Alfresco at work. So, those of you who tell us we're out of touch, it's not true for me in particular. And so she has to use a relatively large Alfresco system. She skipped the training, didn't bother. We regard her as an impatient but technical user, something like that. And one of the things that she had trouble with was coming into a big Alfresco repository. Somebody had set up a very complicated structure that she didn't really understand or care to understand, and was trying to find things in there, obviously using search. So searching for content was giving her problems, and that's because when you type stuff into the search box, it's searching against title, description, and content, and tags, and some other bits and pieces to do with wikis and all sorts of bits and pieces. So content very rarely scores top. If there's something that matches in title, it zooms to the top of the list. So the thing that helped her in particular was using the Google style stuff with name : or content : which helps you search for a particular field. So I'm just trying to help you guys, and maybe the people who you're going to go talk to when you get back home, to improve your user search experience. And one of the things you can do in the search box is type in something a little bit more complicated. You don't have to learn much, you just have to learn name : thing, content : thing, and things will probably improve quite dramatically, especially when you realize that we all things together by default. Even if you put plus in front of terms, excuse me for a moment, we will OR them together because we have an implicit OR. So unless you actually write AND in your query, it will not OR the terms together as you'd expect. So if you're used to Google search, things get ORed, ANDed together. So 2 tips to take away and help your users and our wider community is to consider using specific properties when you know what you're looking for. Most people think, it's in the title, it's in the description. You can hone your result set down pretty well. And remember, if you really want to AND stuff together, either you have to put it in quotes and you're looking for a phrase, or use the AND keyword. Right. That's the end of my digression. So back to the DB engine stuff. Yes, we do support Alfresco FTS with database queries, but if you're going to search against a particular property, you need to tell your query that you want to do exact matching. And that's the first orange box with equals name in there. And the orange is some kind of warning. It's not going to happen magically for you if you're searching against properties, searching against the metadata using Alfresco FTS. You have to make sure you put that equal sign in front of that. And that means you want an exact match. If you don't put it in front of there, the default is to do full text search. And that we don't support in the database, and so it won't go there. Querying for type and aspect and parent and using AND are all good. They'll all work. Path, we've already said, is out, and OR is out. And I've already told you we do implicit OR. So this is the kind of gotcha, is that if you don't put AND in the query, and you think it should go to the database, and you put 2 terms in there, it never will, because the implicit OR may take you in a different direction. It means that you have to do the query against SOLR. Right. So at some point, you are going to have to decide whether DB queries are for you. And it's a balance of SOLR supporting FTS, the eventual consistency, the things and restrictions in the query language against having a consistent transactional result. And it's going to depend on your use case which you want to choose. So if it is for you, are you going to get metadata query magic by default? The answer is maybe. So if you're upgrading to 4.2, you will not get metadata query or against the database unless you set an optional patch to run as part of your upgrade. You can do it after upgrading at any time. You can run the patch, and that effectively adds the indexes to the database to support metadata query. If you were to run that patch, then we'll talk about what the impact is later, but typically you're adding about 25% to your database size because those indexes are quite large, because we're indexing all the string properties that exist in our property table. So there is a cost, and that's what it is. If you install Alfresco 4.2 from clean, then the metadata query stuff will be supported by default. The indexes will be there, and if you don't want them, you'll have to go and remove them by hand. That's the only way there is at the moment. So if you're upgrading, you don't get DB query unless you go and specifically ask for it. And so what happens if you ask for it? So we took a 4.02 database with 10 million nodes in there and upgraded to 4.2. And that upgrade took just over an hour on my laptop as it happened. And it's about the same, that's actually about the same on a real machine, as it were. And the metadata query patch bit of that is 10 minutes. So adding the indexes is not hugely expensive using InnoDB, nor with any other databases, as it turns out. You're paying a price of 25% on your typical database size. You might go from 21 gig to 25 gig, as it happened to be in our particular example. And we did some performance analysis on what that means in terms of the general performance of the product. It turns out most of the time you will not hit the database for queries unless you intend to. In terms of update performance, the cost of managing those extra indexes is a few percent or somewhere in the noise. It is not large, and that's what you'd expect because it only took us 10 minutes to add the index for those 10 million nodes in the first place. So it's not a huge cost in terms of performance, but there is a significant impact in terms of the amount of size it's going to take on disk. However, I'll do a little survey. How many people use compressed rows in their database? There you go. So you could have saved 50% of your database size anyway, so you don't care. No, that's not true, but you know, there are other things you can do to decrease the size of your database impact. And I'm guessing that how many people have actually considered reducing the size of their database in any way at all? So who cares that they're going to have an extra 25%? So we were right, basically, on that one. So that's okay. Right, so the other side of configuration is, when do we use the database? So we've split the configuration to control when the Alfresco full text search uses the database, or SOLR, or tries both, and the same for the seamless query language. So you can configure things to always be eventually consistent, so the query will always go to SOLR in 4.2. You can configure it, well, if you're using Lucene, it will always go to use Lucene. You can configure it so it will always go to the database, and if it cannot execute your query, then it will fail. And you can configure it to be transactional if possible. That means it will look at the query and say, can I execute it against the database? And if I can, I will. And if I can't, I'll fall back to SOLR. And in that configuration, some funny things can happen. You can type a query in and get the results, and you can modify that query. You inadvertently stick OR in there, and it goes to SOLR. It goes a different way, and it might appear slightly different in the results ordering that you wouldn't expect. So that's the only thing that really will impact you there. You can also control this via the Java API on a per query basis. So if you want a particular query to go to the database, you can do that and override these general settings. So the nice thing in Alfresco 4.2, if you haven't seen it already, is the admin screens. This is just to highlight that you can go and change those settings, which are down here at the bottom. I've picked the no index one, so it fits on in some way, and you've got a chance of seeing it. You can always go and refer to it in the slides. So you can change those things live, change your query engine and how it behaves. And you can change lots of other things about the search subsystem configuration on the admin pages if you so desire. They're a good thing in 4.2 and make your life a lot easier, I hope. So I've already said something about performance, and have we introduced a box of worms, I guess is the question you want to know the answer to. It's actually not too bad. Obviously, it isn't as quick as SOLR at doing lots of things, but it's not a disaster by any means. And the performance is pretty good most of the time. And the only time you're going to get into trouble is really doing order by, and when you've got large results in there, and in particular when you're ordering by text. For example, InnoDB, we've got a long string index in there. InnoDB won't actually order by an index based on a text column. No matter how many chickens you sacrifice, it will not happen. And it will always do a post-query order. And if you've got lots of things in there, that takes some time. Again, it's not like the end of the world, but 23 seconds or 24 seconds for a query that orders, I don't know, 5 or 6 million documents, for example. You just want to stay away from that worst case. And again, the only other thing is the database stuff is not quite the same as the SOLR stuff. There's subtleties around permission evaluation and around localization and ordering. And the first question you're going to ask me is, do share queries use the database? And I'm hoping that's a pretty emphatic no. And the reason is, back to slide number 2, there's lots of context added when you execute most of the queries out of share. And the key bit of context is path, and we don't support path. And if you start typing in more than one word, you get caught out by the explicit OR as well, because that's what we do in the UI. We OR terms together by default. So if you want to execute queries that go against the database, what do you need to do? Well, you need to go to the node browser and execute it in a way that doesn't have any context. You have to use the Java API. You have to do some unadulterated search in some way, so you could go to the Open Chemistry workbench, OpenCMS workbench, connect that way. Queries that you execute from there will go against the database if they can, and you stick with a default configuration. Right, a few things in passing. So, as we have introduced the vagaries of DB collation, it turns out that in CMIS 0.6, we flirted with the idea of having upper and lower, and we subsequently removed them. But as we were implementing the query language at that time, they got added, and we haven't removed them for backwards compatibility. So we do support upper and lower to a certain extent. You can do upper and lower on the CMIS name, for example. You can't use it as part of like. You can use it as part of the quality stuff and get away from that case-sensitive, insensitivity stuff if you want to, okay? I've already said it's worth learning a little bit of FTS syntax, not too much, don't get carried away, but learning to use colon for name and description and title and queries against content in particular will help you get back the results that you want to see. When you come to executing queries via the Node browser, there are some query languages that are prefixed with DB, and those ones will go direct to the database. So there's DB CMIS and DB FTS, if I remember correctly. If you use those, you can tell if your query will use the database engine. Because if it doesn't, it will fail using those particular things. It goes direct. Doesn't, like, when you normally execute a query, it will go one way or the other. If you want to make sure you know where you're going, you can do that. There's also some debug you can turn on to find out which way things went as well. And use the admin console. Quite a lot of work has gone into that, and it's a good way to configure your search subsystem in general and to configure the bits that go with metadata query. Have I gone the wrong way? No, that's the Node browser, and just to have an example where we've got a specific DB-based query language selected and we've gone against the database. I'm not going to do any live demos, not because I'm scared, it's just that it's easier that way. So to summarize, we've got a new query engine that can be used to execute some of the queries that you might type in, not from share, but via the CMIS workbench, for example. But it cannot support full text search. If you put OR in there, it won't support it either. We're not going to support float and double, and that's because we don't want to increase the size of the indexes on disk. Who would vote to have support for float, double, and Boolean regardless of the size? That's interesting. Who doesn't care? Who would vote against? Don't know what that tells me. Maybe the microphone needs turning up. I don't know. So we also don't support strings greater than 1024, and we don't support in general queries against complex structure in tree and path, but we do support in folder and parent in terms of the AFTS stuff. And it would be remiss of me not to talk about the future, because you're all interested in what might happen next. I'm not making any promises. I'm not in product development. I think I know what might happen, and this is mostly what it is. So in tree and support for in tree is going to be next, and after that, migrating from SOLR 1.4 to 4 point something or whatever is there at the time. We will look again at permission evaluation. There are some things we can do to further improve that, particularly now that we have to do it after executing a database query. We would like to push something into the database, and we will be considering when we can do that, and performance ties into that. As far as Alfresco 4.2 goes, it's not currently released for all databases, so there are some more to come, and SQL Server and DB2 things will also support querying against metadata using the database. We may roll up simple ORs. So most of the time, well, quite a lot of the time where you would use OR, you can get away with using in. Quite a few of the use cases. And we may be able to roll those use cases where you put OR that could be in up together for you. We haven't done that yet, but we reserve the right to do that on your behalf. Some other things that would make our lives easier is to have date math in there. That always gets talked about, but has not made it to the top of the list yet. At some point, we may change the database schema to make it better for query and better for sort. That may come. And one of the more interesting options is the hybrid mode. So SOLR is very quick, but it's not up to date. The database is up to date, but not so great at some things. Can we put the two together? Can we do SOLR up to 2 hours ago and then add on the database stuff and filter things out? And the answer is, yeah, we clearly could do that. And that's on the list of things we could do. We haven't done it yet, but it's certainly an interesting option. And maybe we could just say, well, you can find content as long as it's been in there for a while and combine the two together. So that, I hope, gives you a flavor for where things might go. We've talked about the DB query engine and executing queries against the database. It's only metadata, and there are some restrictions, and there's some things you don't want to trip over, and hopefully you can refer back to this to work out what those are. And now, I'm ready for questions. Thank you. Yep. I don't know whether there's a microphone running down from there. Yes, there is. Oh, we've gone the other way. It's okay.
I think they were first. Is someone up there first?
Yeah.
So I was wondering, you said something about string length.
Yeah.
I'm not familiar, but the size of a D text, I guess, is somehow variable. It could be bigger or smaller depending on the backend DB. Is that true? A D text you're talking about, no? String.
It's based on Java character length, if I remember correctly.
Yeah. So probably
Derek's
something
at the back,
big.
he might nod. But if I can see him, no, he's run off. It's the Java string length. I think we store slightly more than that.
So my question is this: could it be that if you find something on the DB, and then the user changes a string value on some object?
Yeah, they've had to type in quite a big query. Is the thing. It's possible, but
it's only exact query.
Yeah, it's an exact.
It's no like query.
Yeah.
So you can't have like a wildcard in the query.
You can have wildcards in the CMIS query language, yeah, and you can do it in AFTS as well.
So imagine the following case: I find something like starting with A. Yeah. I find it. Then the user edits that field, adds some content at the back of that field, exceeding the limit.
It's possible.
And then I wouldn't find it anymore.
Yeah.
That's possible. So
it's possible you could change the length of the string and it disappears.
So by changing the data, you could change the resulting objects. Yeah. Because most of your talk is about changing the query.
That's true. Yeah.
And now this is a change in the actual data actually being used, regardless of the query. So this is an interesting point,
but the other thing is that in a typical data set from a big customer with 10 million nodes, and looking at the discrimination in string length, 42 characters is sufficient to do 99.999% discrimination. So the odds that somebody is going to do 102423 and 24 characters is actually minimal.
Okay, so thank you.
So whilst it's technically true, in practice, I think it's just a very specific use case.
But in your talk, you said these types are not supported, so that's constant. This is a variable. Yeah, it's a different flavor of a different kind of effect you have.
Yes. So that particular thing is sensitive to the length of your data.
Okay, thank you.
Hi, I had two questions. First was a really quick one. The default in 4.2 for a new install, is that transactional if possible?
Yes.
Okay, cool. And I just had a quick question about the general usage of the search service in Alfresco in general. I know when we moved to 4, a lot of work was done to pull out a lot of search queries and make them execute against the DB.
Yes.
I'm just wondering if there's anything inside Alfresco that might inadvertently use a DB search service when it hadn't before.
The answer is, because of the contextual bit, not really. Again, there's been we've benchmarked the before and after, the same benchmark, and we haven't hit anything in particular. So I don't think we've missed anything inadvertently, as you said. And I think effectively, if you want to use that DB query engine, you have to specifically craft the query so it will use it. And I don't think we have inadvertently hit anything in Alfresco. And even if we have, it works fine because it's gone through the benchmarking and nothing came out from that in particular. Are there any more questions? Nope. Last
one. Is there something like max permission checks, like with a Lucene query?
Yeah, it's exactly the same.
Okay, so if you want to have more results than 1,000, you have to increase
it goes through exactly the same API as the old Lucene stuff does, and that's also used for things like get children. They all have that kind of limiting stuff in there, so it's exactly the same. I know it's in some ways it's unfortunate, and in some ways it's consistent, but we have actually done quite a lot of work in the kind of 4.1.3 time frame. We improved the permission evaluation and those things quite a lot, and in general, so things have moved on as well, and there are other ideas we have to improve that, both for those use cases and to shift that load onto the database. There's always a risk that the more we move onto the database, obviously the more load we have on there in terms of executing these queries. But we haven't moved lots of stuff over there now. And in terms of the canned query question, I would also say that the indexes that we add typically help in custom canned queries that our partners have added in other places. Like say, I would like to get around this eventual consistency, and I've written my own canned query and it does this, and almost always you want to add the indexes that we've added for metadata query because they help to join to properties and aspects and do the things that you typically want to do. Any more questions? Okay, well, thank you very much for your time.